Good morning, students. Let us discuss a sawtooth wave in Fourier transform, in Fourier series. And of course, this is a schematic diagram of a sawtooth wave. And it has been drawn between f of t and t. T is in the x-axis and f of t is in the y-axis. So we are drawing graph between f of t and t. And this is a sawtooth wave, and it starts with 0 for a complete wave. It ends with 2t. Now we are going to consider two triangles. So there are two triangles. One triangle is this one, and then another one is small triangle. So we are going to consider two triangles. Now let us have some explanation. The periodic is such that the displacement is linear with time from y equals a to when t equals 0 to y equal to 0 when t equal to t. See, here we have one triangle, so it starts from a to ends with t on the y-axis, and f of t is nothing but your y of t. It is a displacement at any time. Then from similar triangles, so we have this triangle and these triangles, so we can have some expressions. So consider two triangles. One is P small t capital T. This is one small triangle. Then another triangle is QOT. See, we have two triangles. One is this triangle and another one is this triangle. Okay, so similar triangles. So out of these two similar triangles, we can have y by a equals t minus t by t. See, here you have y here. So you have y. This is your a. So y by a. And you have t minus t. See, this is t minus t. And bigger triangle will be, this is for t. For smaller triangle, this is t minus t, capital T minus small t. And for bigger triangle, this is capital T. So t minus t by capital T. So we have the relation y by a equals t minus t divided by capital T. Now y equals, taking this a to right hand side, we have a times t minus t divided by t. So a equals 1 minus t by t. So wherever you find y, you can substitute this one. The time axis passes through the lowest point of the periodic curve as shown in the diagram. Now we know Fourier series is given by this expression. So A0 is the DC term, constant term, and this is for cosine term, and this will be your sine term. And to find out the constant A0, so we have the expression 1 by y with 1 by t times y of t dt. Okay, f of t is nothing but your y of t. F of t is nothing but your y of t. So y of t dt. So which is equal to a by t. You just substitute for y. So we have y equals this one. You substitute, we have a by t times 0 to t 1 minus t by t dt. So we have now a by t. After the integration, we have t minus t squared by 2t. Correct? T squared by 2 multiplied by capital T. We will have to integrate with respect to only t, small t. So we have t minus t squared by 2t. So substituting the upper limit will give you capital T. Substituting the lower limit will give you 0. Substituting the upper limit for t squared, that will give t squared by 2t. Okay, taking the LCM, we have 2t squared minus t squared by t. Okay, 2t squared minus t squared will be t squared, and one t will get cancelled, another t will get cancelled. So we have a by 2 for a0. So we have found out now a0, which will have a by 2. Okay, a0 equal to a by 2. Now we go for the cosine term in Fourier series. So cosine term an equals 0 to t y cos n omega t dt. So instead of y, you will have to substitute t minus t by t. So 1 minus t by t. So rest of the terms, let it be cos n omega t dt. Now we are going to integrate. So 0 to t. Now just to separate this one. So we can write 2a by t times 0 to t cos n omega t dt minus 1 by t times 0 to t cos n omega t dt. Now we just take the first term. We are going to integrate both the terms. Just take the first term. We are going to take the first term. So integration, that will give you 2a by t. Integrating cos n omega t, that will give you sin n omega t by n omega. Substituting the upper limit for t, so that will become sin n omega t divided by n omega. We know that omega t equal to 2 pi, correct? T equal to 2 pi by omega, or omega equal to 2 pi by t, we know already. So omega t equal to 2 pi, wherever you find omega t, you substitute 2 pi. Omega t equal to 2 pi. So instead of omega t, you substitute 2 pi here. Instead of omega t, you can substitute 2 pi. Doesn't matter. Okay. So now this becomes sin n 2 pi. You need to substitute the upper limit first, then lower limit. So we have sin n0 divided by n omega. What about sin n 2 pi? Sin n 2 pi becomes 0. Sin 0 also 0. Sin 0 is 0. Sin pi is 0. Sin 2 pi also 0. So this becomes 0 and this also 0. So first term becomes 0. So this becomes 0. Now we will go for the second term. Taking the second term will give you 0 to t, t cos n omega t dt. So we have two variables here, t and cos n omega t. We have two things. So we will have to use only Bernoulli's formula. So Bernoulli's formula goes like this. uv dx equal to uv1 minus u prime v2 plus u double prime v3. Here u is nothing but differentiation, whereas v is nothing but integration. So you have to remember. So here we are going to take u as t and v is nothing but your cos n omega t. So you have to differentiate this one and you have to integrate this one and use the formula, Bernoulli's formula. We can solve the second term. So u t differentiating will give you 1. What is the double differentiation? 0. So we can't go further then. So we can have only two terms. We can't go further. Now v equals cos n omega t. Your v1, integration of v1 will give you cos n omega t dx. That will give you sin n omega t n omega. So there's a mistake here. It is dt. There's a mistake here. It is omega t dt. Here too dt. In the general formula it is dx. According to this problem, this becomes dt. Okay, this is also dt. On integration, that will give you sin n omega t divided by n omega, and v2 equals sin n omega t n omega dt integration. That will give you minus cos n omega t divided by n omega. So that will give us n squared omega squared. Okay. Now you have to use the Bernoulli's formula. Bernoulli's formula is u v1. So you have to multiply this and this. You have to multiply this and this. 1. Second one will be minus. You have to multiply this and this. The second term. So okay, it's easy to remember. You multiply t multiplied by sin n omega t by n omega. That will be the first term. See, this will be the first term. And second term will be with a minus sign. You multiply 1 multiplied by minus cos n omega t divided by n omega with the limits. That's all. So second term becomes. So you have minus sign. We have minus sign. So in the second term we have minus sign. So we have minus sign here. 2a by t squared. This is your first term. This one and this one will give first term. So that will be t sin n omega t divided by n omega. One minus is there. Here also one minus is there. So minus plus it becomes. So cos n omega t divided by n squared omega squared. Now we can substitute upper limit and lower limit. So substituting the upper limit will give you capital T. Substituting lower limit will give you 0. Okay. So I have written the same thing here. And we are going to substitute upper limit, that will give omega t. Instead of omega t, you can substitute 2 pi. So this becomes t sin n 2 pi omega t. Okay, 2 pi. And this becomes n 2 pi cos n 2 pi divided by n squared omega squared minus cos 0 divided by n squared omega squared. Okay. So here we have substituted now. What is this term? This term is 0. Because sin n 2 pi is 0, sin 0 also 0, so this term will go off. So we can have only these two terms. So this becomes cos n 2 pi divided by n squared omega squared. Now I have multiplied n minus sign with this one, this term. So I have written interchange. I have interchangeably written. See, this term comes first and this term goes second. Because I have inserted now minus sign. Okay. So cos 0 is the first term. Second term will be cos n 2 pi. Cos 0 is 1. Cos 2 pi also 1. Okay, cos 2 pi, cos n 2 pi, that also be 1. So 1 minus 1, 0, and your an also 0. Okay, an 0 means the cosine term is not there. Cosine term contains only an. Sine term contains bn. See, in the Fourier series, we have two terms. See here, we have two terms, an and bn. This is for the cosine term, and this is for the sine term. cosine term becomes 0 here. So that's why it's written here cosine term disappears. Okay, cosine term in the Fourier series disappears. Now we'll go for the sine term. Bn, we'll have to calculate Bn now. Bn equals 2 divided by t, y sine n omega t dt. Instead of y, you'll have to substitute this one. Okay, now remove the bracket, you'll have to separately convert. Okay, so this becomes sine n omega t dt, and this becomes minus this t. Here you have written t, I have inserted. Okay, so t divided by t sine n omega t dt. So now we'll go for the second term using Bernoulli's formula. So Bernoulli's formula is like this. So here u equals t and your v will be sine n omega t. Okay, so u prime will be 1, and what of sine n omega t dt? Again, there's a mistake here. This is dt, which is equal to minus cos n omega t divided by n omega. And after that, to calculate v2, we have v2 equals minus cos this term cos n omega t divided by n omega. Integrating that will give you sine n omega t divided by n omega. Already one n omega is there, so this becomes n squared omega squared. Now using the Bernoulli's formula, you have to multiply these two terms and these two terms. Okay, so these two terms. So this is for second term. What was the first term? First term is 0. First term. So second term becomes 2a by t. Second term 2a by t. So this becomes this multiplied by this term. This multiplied by this term. So that will give you minus cos n omega t divided by n omega 0 to t minus 1 by t. 1 by t is common, so 1 by t. So minus t cos n omega t divided by n omega. No, directly you can do. See here, 1 minute. So this is your first term and this will be your second term. Correct? So on integration of the first term will give you this. Integration of the second term will give you Bernoulli's theorem. You have to use Bernoulli's theorem and we have this term. Okay. See, integration of the first term will give you this minus cos n omega t divided by n omega. This is for the second term. Okay. See here, we have taken only the second term, and we have used Bernoulli's formula. And we have obtained the results for the second term. So I have inserted here second term, and this is for the first term. First term is here, integration of sine n omega t dt. So on integration that will give you cos n omega t divided minus cos n omega t divided by n omega. So now you have to substitute upper limit and lower limit. Substituting the upper limit will give you minus cos n omega t n omega. Already one minus is there, and you have to use the lower limit. One more minus is there, so minus will become plus. So what about cos 0? Cos 0 is 1, so that's why 1 by n omega. Is it okay? Now substituting the upper limit will give you capital T cos n omega t divided by n omega. Substituting the lower limit will give you cos 0, t is 0, cos 0 is 1, but t equals 0, so this term will go off. And substituting the upper limit for the second term will give you minus n omega t, n squared omega t, sin 0 is 0, so last term becomes 0. Okay, now instead of omega t, you can substitute 2 pi, so minus cos n 2 pi divided by n omega. 1 by n omega, let it be less as it is. Now we have minus 1 by t. This t and this t will get cancelled. We have cos n omega t. Instead of omega t, you can substitute 2 pi. So cos n 2 pi divided by n omega. As I said earlier, this becomes 0. You have to substitute for omega t, which is equal to 2 pi. So sin n 2 pi divided by n squared omega squared. This 1 by t is here, 1 by t. And of course we know that sin 2 pi is 0. So this term will go off. And you can strike these two terms. See here? We can strike these two terms. This is minus, this is plus of same terms. So this one will go off. Your remaining term will be 1 by n omega alone for the Bn. So your Bn will be 2a by t 1 by n omega. This is for the sine term in the cosine series. Sine term in the Fourier series. So 2a by t times 1 by n omega. Correct? And omega t equal to 2 pi. So here omega t is there. So we can substitute for omega t, can substitute 2 pi. So we have 2a divided by 2 pi n 2 will get cancelled. We have a divided by pi r. Therefore, now the amplitudes of the coefficient. Now, when I want to substitute for n equals 1, this becomes a by pi. N equals 2. So, b2 becomes a by 2 pi. For n equal to 3. So, b3 equals a by 3 pi and goes on. So, your Fourier series becomes f of t equals your constant term, your cosine term, this will be your sine term. We know already cosine term becomes 0. So, we don't bother about this. And we have now a0 is nothing but a by 2. We have already calculated. So, a0 is nothing but a by 2. Your an equal to 0. So, the second term will disappear. And third term will be, we have already calculated C, b1, b2, b3. We can expand it. So, that will give us, taking the common terms out, a by pi, here also a by pi. So, that becomes a by pi common out. Remaining term will be sine 1 omega t. See, sine 1 omega t. Second term will be sine 2 omega t, 1 by 2. Plus 1 by 3 times sine 3 omega t, dot dot dot, 1 by n times sine n omega t. So, this is your Fourier series, f of t or y of t. So, the addition of successive terms is represented in the figure. So, this figure is very important. The curve indicates, so this is the curve. The curve indicates the resultant curve tends to resemble with that to be analyzed as we increase the number of terms in class. It just, the first term is involved here. Second term, look at the second term and look at the 3 terms involved in the figure. Now 10 terms, see 10 terms. It's almost here 24 times. So similarly we can go for 48 times. So 96 times. And almost you will get a straight line. Okay, at the end you will get a straight line. Okay, we'll start today. Let us discuss half-wave rectifier in Fourier series. So this is your half-wave rectifier. And of course we know when electric signal is passed through the small diode, only one diode, we will have DC. That is half-wave rectifier, as we have already done in the lab. For the full-wave rectifier, we will have to use 2 diodes for full-wave rectifier. For half-wave rectifier, only one diode. The output is nothing but your half-wave rectifier. So this is for half-wave rectifier. Okay, the complete cycle will be, this is your complete cycle, 0 to t. The full wave, see this is a full wave, but half wave only exists. Another half wave it is 0. See here, another half wave it is 0. Okay, so this is called a half wave rectifier, which you have done already in the